We're continuing our discussion of synthetic division and how it helps us to find the zeros and the factors of a function. So this matches your homework problems. So a first example, the directions might ask you to use synthetic division to find out whether the second polynomial is a factor of the first. So in old-fashioned language, does this factor go into this polynomial? So we've found out that we could do long division, or we could just use the coefficients and do the synthetic division process. And I guess our textbook draws this line up here and then another line down here, sorry. And if x plus 4 is a factor, then that would mean that negative 4 would be the zero. So that's our question. So remember, if x plus 4 is the factor, that we want to change the sign and find synthetic division here by negative 4. So we bring down the 5 to start the process. We multiply 5 times negative 4. We add the columns. Then we always multiply times the negative 4. We add the columns, multiply, add, multiply, and there's our zero remainder. So the question here said, is x plus 4 a factor of 5x plus 16x cubed minus 15x squared plus 8x plus 16? And the answer is yes. So we could finish the problem as easily as that, or we could be more specific and we could show that when we divide the original polynomial divided by x plus 4, we can see what our result is. And that's the important idea here, that we got 0 as a remainder. So what we've found out is that when we divide, we ended up with 5x to the third minus 4x squared plus x plus 4. And we also learned that another way of writing this would be to take the divisor and multiply it to the other side. And that's going to be handy in our next example. In example 2, we are asked to factor the function into linear functions, given that the value of k, here we're given a value of negative 5 for k, given that k is a 0. So what do we mean by this? The term linear, remember, means first power or first degree. So we want to break this third degree polynomial down into its linear factors. So how can we get to a third degree? We would have to multiply 3 first power factors. Well, they're giving us our starting point here. So what these directions are telling us is that when we do synthetic division by negative 5, we should expect a 0 remainder, because the directions tell us that negative 5 is a 0 of the function. So let's check it out and make sure. And if we get an error here, it might be from a copying error, transcribing, or an arithmetic error. So here we get 65. 2 times negative 5, sure enough, it worked fine. So now what do we know? We know that x plus 5, if negative 5 is a 0, then x plus 5 is a factor. And what's our remaining factor? Well, here's what we found out. 6x cubed plus 17x squared minus 63x plus 10 is equivalent to x plus 5 times, and now our remaining factor comes from our coefficients here in the bottom. That's what synthetic division tells us, is we've located one factor, and not only that, but now we know the remaining factor. And now we need to break that one down. Well, if it is factorable, and the relationship here suggests to me that it is, that we don't need to do quadratic formula, I'm thinking that putting a 2 here And let's make them both negative so that we get a positive. So I'm thinking that a negative 12x and a negative 1x is going to work. So if we weren't able to solve that quadratic or factor that quadratic by reverse of FOIL, we would go to quadratic formula, or you could try some more synthetic divisions, and that's what we'll be doing in the next lesson. Okay, let's just try one more of these. Same process. They're giving us a polynomial f, a function f, and not only that, they are telling us one of the answers. So they're telling us that 1 is a 0. So again, we are expecting to get a remainder of 0 if the given tells us that 1 is a 0. So let's check it out here. And I like that it worked out. So what do we know is our remaining factor? We know that 2x cubed, our original function, minus 3x squared minus 5x plus 6, is equal to the factor. Now be careful, if 1 is the 0, then it came from x minus 1 as the factor, and the other factor comes from our coefficients here. And let's see if we're lucky again. If we have to, we can go to quadratic formula, but I think we can make this work with a negative 3 here and a positive 2 here. Remember that we couldn't put the 2 in the first parentheses because then it would have a GCF. So remember, your factoring tricks is going to make your homework quicker. And that's really all there is to it.